Okay, recording is now on. Welcome to physics, the last class before we have our first midterm. Ooh, okay. I know that several of you are concerned, shall we say. Um, I hope that you're not too freaked out about it. The test shouldn't be horribly difficult. I'm going to talk more about it in a few minutes. I'm going to explain how it's laid out and how we're going to take it and all. But for right now, let's jump into the homework quiz. And then we'll talk about the homework, and then we'll go in more into the test and also the practice test. Okay, so right now, you guys know what to do. You know you know how the game is played here. So the quiz is now unlocked. Everybody, please go take the quiz. There are only 2 questions. You should be able to finish in 5 minutes if you learned what you're supposed to have learned from the homework. So go get doing that. I'll pause the recording. No sense in sitting here and letting that run. All right, I just resumed the recording. We've got one person. 3, 2, 1, 0. Okay. Oops, I missed one. There's one more down here. 14 seconds to go down here. Okay, so those of you that are now finished, or actually let's wait 5 seconds, then everybody will be done. Okay, good. All right, everybody's done now. All right, so I see several 10s in there. That's good. I see a fair number of 5. So there's only 2 questions, so either got 0, 5, or 10. Some of you got 10s, and I'm glad to see that. A lot of you got 5s. Some of you got 0s. And I realize that a big part of what you're fighting here is time. I realize that 5-minute time limit puts a lot of pressure on you and you freak out. You know that you can retake every quiz that we do. So I hope you don't feel too much stress. But this is important feedback for me. And what it tells me, I'm seeing enough scores that are not 10, that it tells me that you guys are not yet ready to take the test next week. And I anticipated that. So you may have heard, or you may have noticed on Canvas, that I am setting up a tutoring session on Friday, so tomorrow, between 2 and 4, even though Friday is not a school day. It's a holiday because of parent-teacher conference on Monday, Tuesday, so they give us Friday off. But I'm just such an incredibly nice guy that I'm going to help you guys out. So from 2 to 4 tomorrow, I'll be on Zoom. Thank you, Sam. Okay, good. See, I'm not always a bad guy. Okay. Okay, so it's optional. You don't have to be there if you don't want, but I think that it will definitely help you score better on next week's test if you do that. But before we talk about that, let's talk about the homework last night. And so, okay, don't want that. Here's what we want. All right, so here are the answers. Not that one, this one. Okay, here are the answers to the ones that you haven't already looked up in the back of the book. And I saw that somebody just typed something in the chat box, but when I share, my chat box goes away. Okay, there it's back. Okay. All right. Okay. Are there any questions about the homework? Not hearing any. And my chat box went away again. This is a bug we really got to get fixed on Zoom.
How do you determine like what makes what you need to be negative to get a negative answer? Because that's my biggest problem.
Okay. Well, if you look at problem number 42, that's where it really came up here. So you'll notice that my preferred answer for problem number 42 is 39 meters per second downward. Some of you may have written negative 39 as your answer, but I prefer to say 39 meters per second downward because those of you that said negative 39, presumably you chose your positive direction to be up, which is what most people like to do. But see, the trouble is that you don't have to choose the positive direction to be up. You are free to choose the positive direction to be down if you want, right? And so if you just say negative 32 without telling me what direction you chose as positive, that doesn't really tell me what I need to know. So on problem number 42, we know that the thing is moving downward. And so when we calculate the speed as 39, just say 39 downward rather than negative 39. Does that answer your question?
Sort of.
Sort of. Okay. Here, let me rephrase it again and see if we can do better the second time around. Okay, when you started into the problem, I presume that you chose a direction for your positive. You should have done that. I mean, there's two things you have to do at the beginning of every problem. You have to decide where you're going to put your origin, and you have to decide what direction do you want to be positive. Okay, so I'm going to presume that you chose the positive direction to be upward, because that's what most people like. So once you do that, then you go through the math, and when the number comes out on your calculator, if it comes out as a negative number, then you know that it's downward because you define plus up. So if it's the negative on your calculator, then that must mean downward. So I don't know what more to say other than that. All right, so Jackson is asking, how do you determine which formulas to use and when to use them? That is the main part of what we're going to be talking about today. I mean, I did talk about it before, and what I'm going to say today isn't really any different from what I said before, but maybe just formalize it a little bit better. When we do a problem, well, in fact, let's pick one. Well, so hold off, Jackson. When we do a problem, I'm going to talk about that. I'll talk about the procedure I want to go through, but we got to have a problem to do. Anybody want to pick a problem? Or are you good on all of them? 44, okay, can do. Let's do 44. And let's do it in a way that answers Jackson's question. All right, so problem number 44, we got a student dropping the ball and we don't know how fast it's moving when it hits the sidewalk. Okay, good. Right, this is a perfect example for what we want to do for Jackson. Okay, so let me go down to this page right here. This is something that you've seen before, just in a slightly different format. These are the equations of motion, and hopefully you guys know that I posted a file on Canvas that is just these equations. All right. In addition, I posted something yesterday that wasn't there before. Some of you may have noticed, some of you may not. I posted a thing that I called the template for solving accelerated motion problems. And what you're seeing on the screen right now is that template. So it's just a PDF file that looks exactly like what you see on the screen. And so I'm going to use that template to solve problem number 44. And hopefully you will see from how we do this, the answer to Jackson's question, which, in case you've forgotten, is how do you determine which formula to use and when to use them? All right, so let's do that then. All right, so I'm going to start by drawing a picture of the problem. All right, so it says they drop a ball from a window 3.5 meters above the sidewalk. Okay, so let's draw a picture. So here's the sidewalk, here's the building, here's the window, here's the student sticking their arm out, big long arm. Okay, so this is the starting point, and we know that it's 3.5 meters from there to the ground. All right, so we're going to drop the ball. Notice they said drop as opposed to throw, because the other option is we could have thrown the ball. So when you hear the word drop, or when you read the word drop, that's a code word that says to you that the initial velocity must be 0. Because if it was not 0, then we wouldn't be dropping it, we would be throwing it. All right, so drop tells us initial velocity is 0. Okay. So now, remember I said the two things we have to decide before we start any problem. We have to figure out where is the origin, and we need to figure out what is the direction for positive. Is it up or is it down or right or left or what? All right, now I see two logical candidates for where we might draw our origin. So one idea is to put the origin up here where the ball starts out, which is what most people like, to put the origin at the place where the ball is initially. But we don't have to. And we can do it down here if we want. We can be different, put the origin down here. Or if we really wanted to, we could put the origin somewhere in between. There's no law that says you couldn't do that. Okay. Oops, I didn't mean to do that. Well, too bad. I just did it. Okay. So let's read. Oops. Okay, let's try that again. Let's redraw our picture. Okay, so here's the ball, 3.5 meters. Okay, so Jackson, where would you like to put your origin? You want to put it up where the ball initially starts, or do you want to put it down at the bottom? You got to pick one. Okay, where the ball starts, okay? So Jackson likes to be a conformist, all right? If it was Sam doing it, she would have done it down at the bottom, I'm sure. All right, so we need to figure out what numbers to put in here for X naught, XF, V naught, VF, all that fun stuff. Okay, so, whoops, okay, here goes. All right. Okay, so because we chose the origin to be at the place where the ball starts out, then I hope that you guys all understand that that by definition means that X initial must be 0. Because what is it that X represents? X is the position, and when we talked a lot about position vectors versus displacement vectors. The position vector is the vector that starts at the origin and ends where the object is at any given time. So in other words, the X value is how far away from the origin is the object at any given time. So X initial is how far is the ball from the origin when we start the clock. And because Jackson decided he wanted to put his origin up here, our X initial is 0. Now, X final is either going to be positive 3.5 or negative 3.5, depending on how we want to define our plus direction. Now, most people like to have the plus direction be up. You don't have to if you don't want, okay? But seeing as how we're being conformist anyway, let's be conformist again. So when the ball hits the ground, it is below the origin, which means it's on the negative side of the origin. So that means that when we stop the clock, X final is going to equal negative 3.5. Okay, and that's a point there. It may not look like it, but it's a point. Okay, all right. V initial we decided was 0, and that's because we used the word drop rather than throw. V final, well, just looking at the picture here, we don't know. And hey, if I remember right, that was what they asked was for, right? Is this, yeah, okay. So V final is what we were asking for. So I like to put a box around that, just to remind myself that that's what we're looking for. All right, now, some of you might be tempted to say, well, wait a minute, Mr. Hendricks, wouldn't V final be 0? Because after the ball hits the ground, the velocity is going to be 0, duh, right? Don't fall into that trap. These equations of motion that you see right here, these equations only apply when the ball is in the air. If the ball hits the ground, these equations no longer apply, right? So when we talk about V final, we're not talking about what's the velocity after it hits the ground. We're talking about what is the velocity in that tiny fraction of a second just before it hits the ground. All right, now we also need to fill in the rest of the variables here. So I see acceleration, and I'm reading the problem, and nowhere in the problem do they say what the acceleration is. So I stroke my chin and say, if only there was a way I could know what the acceleration is. Anybody got any suggestions? Do we know what planet we're on?
9.8.
9.8, very good, yes. As long as we're on the planet Earth, we can assume that the acceleration is 9.8 downward, because when we drop the ball, it doesn't fly upward, it flies downward, right? So 9.8 downward. Now, if we were on another planet, which by the way, when we take the test next week, we might be on another, the problem might ask about another planet. So be prepared for that possibility. Now, if I were to do that, I would have to tell you what the acceleration due to gravity is on that planet. Okay, so we know that the acceleration is 9.8, but is it positive 9.8 or negative 9.8? Notice we defined the plus direction to be up, okay? And since things accelerate downward, yeah, it definitely has to be negative 9.8. Don't forget that negative sign. That'll mess everything up. Okay, and then the last thing is the time. So let me look again on the problem. I don't remember them telling us the time. Yep, they do not tell us the time. Okay, so I'm just going to have to put a question mark right here. Okay, so now we get to the part of the process that most people have trouble with, but if you approach it right, it's actually incredibly easy. So let me ask you two questions. What variable are we trying to solve for? Well, the answer is VF. Okay, so whichever one of these equations over here we pick, it darn well better have a VF in it, otherwise it's not going to help us. Okay, but at the same time, notice that we don't know what T is. So whichever of these equations over here we pick, it darn well better not have a T in it, because if it has a T in it, then we're gonna have a problem, because then we're gonna have two unknowns and only one equation. And you guys, I trust you know that if you got two unknowns, you need to have two equations, right? So now it is possible that if we were combine several of these equations together, we could actually solve it that way. Could be done. But I like to do things the easy way. So I want to find one equation, and that one equation had darn well better have a VF in it, and it better not have a T in it. So do you guys see any equations that meet those requirements? You see an equation that's got a VF in it and does not have a T in it? Come on, somebody needs to type something here.
The third one.
The third one down, yeah, the VF squared one. That's the one we want. Okay, so now we know which equation to use. All right, so from this point on, it's no longer a physics question. Now it's just a math question, and you're good at math, right? Okay, well, let's find out. So I'm going to take the equation, and I'm going to write it down here. So VF squared equals V naught squared plus 2A. Now delta X, how about let's just write that as X final minus X initial, because that's what delta X means. All right. Okay, so now I just need to solve for V final. And hey, I'm thinking I don't even need to do any algebra this time. I mean, normally, like we're solving for A or something, and so we have to do a bunch of algebra in order to solve for it. But this time around, we don't even have to do that. The equation's already in the form that we need. So at this point on, it's just plug and chug. So V initial right there, which was 0 anyway. The acceleration, negative 9.8, plug that in there. X initial was 0, plug that in there. And X final was negative 3.5. Don't forget the negative. If you leave out the negative, you're going to get the wrong answer. Okay, so now it's just plug and chug. And when you're done, you should get the answer that, let's see. Okay. Okay, you should get this answer on this page right here. So hopefully that answers your question there, Jackson. And I'm sure that everybody else had the same, or I'm sure that many other people had the same question. Okay, are there any other questions about any of the homework problems? All right, you'll notice that I said that I wanted to discuss problem number 48 and also problem number 52, right? So let's talk about number 48. Okay, so 48 is saying, let's suppose we throw a ball straight up and we want to describe the changes in the velocity of the ball and the acceleration. Okay, so Here's the ground level, here's the ball. So when the ball leaves our hand, it's traveling at some speed. Let's just say 30 meters per second, just for grins there, just so we have a number. So 30 meters per second is how fast it's going. Now, we know that if we're on the planet of the planet Earth, the acceleration is 9.8 meters per second per second. So it means every second that goes by, the acceleration changes by 9.8, but it's in the downward direction. So if we want to be conformist here, if we want to decide that our plus is up, then we need to put a minus in front of that. Now, 9.8 is a number that's pretty close to 10. So if we, just for the sake of discussion here, let's keep it easy. Let's assume that it's not really 9.8, it's actually 10. So 1 second after I throw that ball, okay, it's now moving slower. So notice my arrow is shorter, and it's going to be moving 10 meters per second slower. So 20. 1 second after that, now it's moving up, and now it's at 10 meters per second. 1 second after that, it stopped. My velocity is now 0. Another second after that, it's now moving 10 meters per second downward. Another second after that, it's moving 20 meters per second downward. Then finally, 30 meters per second downward. So the velocity is changing, and every second that goes by, this right here, negative 9.8, is how much the velocity has changed as each second goes by. Right? So that's a discussion of how the velocity changes. And then the question also says, discuss the changes in the acceleration. Well, does the acceleration even change? The answer to that is no. Every single time here, if I look at the difference between these two guys here, the difference is 10 seconds, or actually 9.8. If I look at the difference here, it's 9.8. Here, it's every second that goes by, the velocity changes by the same amount. So the acceleration is constant. It doesn't change, even up at the top. Now, a lot of people have trouble up here at the top here because they think that if the velocity is 0, well, the acceleration must be 0 too. No, it's not. Because a tiny fraction of a second before it reached the top, it had some positive velocity. A tiny fraction of a second after it reached the top, it had some negative velocity. It was only at velocity equals 0 for an infinitesimally small period of time. And so even though the velocity was 0 at that infinitesimally small period of time, the velocity was still changing. All right, so Sam is asking, will the acceleration always be constant? Well, let's say you're driving your car and you put your foot on the gas. As long as you put a constant pressure on the gas pedal, your acceleration will be constant. But I don't know about you guys. I've driven with people, or I've ridden in car where people are driving, and they just go crazy with the gas pedal. You know, they push it for a while and then they let off, and then they push it for a while and then they let off. Okay, so in that case, the acceleration is most definitely not constant. But anytime that we're talking about things that are falling, you know, free fall, the only force that's acting on it is gravity. And as long as you stay on the surface of the Earth, or as long as you're near the surface of the Earth, that force of gravity is going to be the same. Now, if you start getting further out into space, it gets complicated. We'll talk more about that later. But for any of the problems that we're going to be doing for the next couple of weeks, the acceleration will definitely always be constant. Okay. And question number 52 is asking basically the same thing. So Sam is asking, the acceleration will always be 9.8. The answer to that question is, if you're on the surface of the Earth, yes. Okay. Oh yeah, Taituan is way ahead of me there. So be careful, because when I give you the test next week, I might say that I've got an astronaut on some other planet, and the acceleration on that other planet will not be 9.8. So Adam is saying that if you're on Earth and if you're in free fall, then it will be 9.8. And you are 100% correct in saying that. Okay, last chance for questions on the homework. So Taituan is asking about gravity on the sun. The gravity on the sun is going to be very different. Acceleration due to gravity on the sun will be much greater than 9.8. But we'll talk more about that later. All right, I'm not seeing any more questions. I'm not hearing any more. So let's move on to new stuff. Okay. I trust you guys have looked on Canvas recently. So let me go to my Canvas page here. And then I'm going to share my screen with you. All right, you should now be seeing my Canvas page. All right, so let's click on the physics page and scroll down and click on the assignments. Okay, this should look familiar. So module 1 there, that was the how physicists do physics. Module 2 now is the one that we are just now finishing up. And there are a couple of things on here that I added just yesterday. So if you haven't looked on Canvas in the last 24 hours, then some of these things here will be new to you. Okay, so you'll see the practice test. Well, I actually posted that quite a while ago. I'm hoping that many of you have already downloaded the practice test and started working on it. We are going to talk some more about the practice test in just a few minutes. In fact, my plan is that after I tell you a few procedural things so that you're prepared, so you know how we're going to be giving the test next week, after I finish that, we're going to spend the rest of the period talking about the practice test. Now, that will not be enough time to talk about all of the problems on the practice test. And so you'll see down here, I've set up a tutoring session for this Friday, which I've already told you about. Okay, notice that it is optional. You do not have to attend if you don't want, and it's not even worth any points. It's 0 points right there. So you don't get any points by attending on Friday, but I do think that indirectly it'll help because you will get more points on the test next week if you attend Friday. So it's totally up for you. Okay, now also you'll notice this file right here, this is new. This is the file that I just got through showing you. It's the piece of paper where over on the right side, it's got all of the equations of motion, the ones that I like to call the Dr. Seuss equations because, you know, the hop on pop picture there. And over on the left side, it's got all the variables from those. Okay, so that's what this template is that you see right here. And I really think that it'll help you. So I highly recommend that you that you print out that template, or if you don't have a printer, then just, you know, create your own, just write it down. And so I see a question in the chat box. Yeah, the tutoring session is from 2 o'clock until 4 o'clock. That is the case. Okay. So let's talk more about the test next week. I want to make sure that everybody knows what to expect and where you need to go. Now, I'm aware that some of your AIMS teachers, they require that when you take a test, you have to log on to Zoom and you have to turn on your camera so that the teacher can watch while you take the test. I kind of sort of understand why they do that, but I don't believe that it's really going to accomplish any good, because if somebody wants to cheat, they could easily cheat even though the camera's on. And so I say, well, why even go through motions then? I'm just going to let you take the test without signing on to Zoom first. So next week, when it's time for class to start, just don't even bother logging on to Zoom, just go right straight into Canvas. The test will be there, and now it'll be locked right up until the time the class starts. And by the way, you know how we have this 10-minute delay period built in every class period? I'm going to stick with that. So if you're in the 4th period class, which is the one that I'm talking to live right now, so the class officially starts at 12:44, but the Canvas is going to be locked, or at least the test is going to be locked in Canvas until 12:54. Now, if you are one of the students in the 3rd period class and you're watching this recording on Zoom, you know, 3rd period starts at 10:38. And so I'm going to give you a 10-minute period there. So at 10:48, that's when Canvas will unlock the test and you can start the test. you will then have 80 minutes to finish the test. Now, because there's no way that I could prevent you from using your notes or looking in the book, there's no way I could prevent that. So I allow it. It will be okay. It is not cheating for you to use your notebook, to use your textbook. You could even go and Google stuff if you wanted. Now, it would be cheating if you were to ask somebody for help. So if you have a friend sitting next to you or a parent or somebody and you turn to them and ask them, that would be cheating. So any non-human source is okay, but a human source is definitely not okay. Okay. So Austin is saying you don't need to go to Zoom next week. And so that is the case. But Austin, this is the 8A class. For you guys, the test is going to be on Tuesday because, Friday is a day off. It doesn't count as an A or a B day. So those of you in the 8A class, the test for you is going to be on Tuesday. It's the B day class is going to be on Monday. Okay. All right. So yeah, you can go ahead and use the textbook if you want. But here's the thing, okay? Because I know that you might want to look up the test question on the book, I have designed the test so that if you have to frantically flip through the book and read the book in order to figure out how to do a problem, you're going to run out of time, okay? The test is designed so that it can be done in 80 minutes, but only by someone who doesn't need to waste any time looking in the book. Okay? So here's what I recommend that you do. I recommend that you create what I call a cheat sheet. One piece of paper. You can write anything you want on that paper. You can write front and back on the paper. So I would recommend that you go through your notes and pick out all the important stuff or whatever you think is important. Go through your textbook, pick out all the important stuff. Get everything that you think is important on one sheet of paper. That's what I call a cheat sheet. And have that piece of paper sitting right there while you take the test. That way you don't have to waste time flipping through the book looking for stuff. You got it right there. Because I guarantee you, if you spend time flipping through the book, you are not going to finish the test in the allotted 80 minutes. All right, so Amy wants to know how many questions will it be? Yeah, I haven't decided yet. I'm still in the process of writing it. But I don't really care about the number of questions. It's how long it takes. So, I will judge how long I think it's going to take, and I'll adjust the number of questions accordingly to where it can be done in 80 minutes by someone who does not need to flip through the book. Okay, let's see, what else? Oh yeah, really important thing. Okay, so the first several questions are going to be ones that I think are relatively easy, and I'm going to put them in multiple choice format. So you should be able to whip through those pretty quickly and just, multiple choice. Pick the right answer out of the various choices available. Then the remaining questions on the test are going to be ones where it's not multiple choice. You are going to have to get out a piece of paper and you're going to have to write, and you're going to have to do some figuring, you're going to have to do some calculating. Make sure you have a calculator. Okay? And at the end, you are going to write the number into the text box on Canvas. If you write the correct number, you will get the full credit. If you write the wrong number, then what do we do? What do we do? Okay, because I recognize that it's incredibly easy to make a silly mistake along the way, because boy, I certainly do it a lot. I've worn the wig enough times to know that how easy it is to make a silly mistake. So what I'm going to do is this. While you're working the problems and you're writing on the paper and you're figuring everything out, okay, save that piece of paper. And then after the test is over and after Canvas is closed, and the time limit's up, then I want you to take that piece of paper that you wrote all your work on, take a photograph of it, and email it to me. Now, what I'm going to do when I grade the test is I'm going to let Canvas do all the grading. And if your answer is right, Canvas will mark it right, and I won't even look at it. But if Canvas marks it wrong, then I will look to see if I have an email from you. And if I have an email from you showing your work, what I will do then is I will look at your work and see the steps that you went through to come up with the answer. And if I can see that you knew what you were doing, you just made a silly algebra mistake somewhere, you dropped a minus sign or did something equally silly, I'll give you 4 out of the 5 points. And by the way, all of these problems where you have to work out an answer and write the answer into the text box, those problems are all going to be worth 5 points. The multiple choice questions, they're only be worth 2 points each. Okay, so if you get one of the 5-point questions wrong, I will look to see if you've emailed me something and see if I can give you partial credit. Now, the first thing that I'm going to check is I'm going to make sure that the answer that you typed into the box on Canvas is the same as the answer that's shown on your paper. If those two numbers are not the same, I'm going to seriously question your honesty, because I'm going to suspect that what you did was that after the time ran out, that you kept on working on the test and you tried to sneak in an answer after the time limit was up. And so if the answer written on your piece of paper that you photographed and emailed to me does not match the answer that you typed into Canvas, I'm not going to give you any extra credit, and I'm going to send you an email asking what's the deal. So as long as those two answers match, then I'll look at what you wrote and I'll decide whether or not to give you partial credit. Now, if you've talked with any of the students from last year, they will tell you that I'm generous with partial credit. I mean, as long as I can see that you basically knew what you were doing. I mean, if what I see on the paper shows me that you had no idea what you were doing, well, then I can't give you partial credit. But as long as I can see that it was just a silly mistake, I will be very generous with partial credit. I'll give you 4 out of the 5 points, or maybe 3 out of the 5, depending. Okay. So I'm on your side. I really am. I'm not looking for excuses to take points away from you. I'm looking for excuses to give you partial credit. That's the way I do things. Okay, so those are the logistics for how the test is going to work next week. Does anybody have any questions about that, how the test is going to work? Okay, not seeing anything, not hearing anything.
What if our Wi-Fi would go down during the middle of the test?
Yeah, that could happen. If that's the case, send me an email and we'll work something out. Also, that brings up another question that I was going to talk about. I'm glad you kind of reminded me. There are some students who have a special deal worked out with Ames where you are allowed more time on the tests. Now, it's not easy to get this special deal worked out. The only way you can get it worked out is your parents have to meet with the counselors, and your parents have to explain to the counselors why you need that extra time. And so if you are one of those students who has a special deal like that worked out, you need to email me ahead of time before the day of the test. And then we will work out a way where you can get the extra time that you need. We'll figure out a way, maybe I'll just let you stay a little late, and the whatever is the period after this one, you'll just be late to that period. Or I don't know, we'll work something out. But you got to email me ahead of time. Don't email me afterwards. It's got to be ahead of time. Okay. Well, tell you what, let's use the rest of the period here to talk about the practice test. So I'm going to share my screen again. All right, so you should now be seeing my screen. And so the practice test, I'm hoping that you guys have already downloaded it because I posted it on Canvas quite a while ago. The answers to the practice test, I also posted those, except I locked them up until this morning. They are now unlocked, but prior to that, they had been locked. Oops, sorry, there we go. Okay, so tell you what I'm going to do right now is let's go into the practice test, the version that does not have the answers. And so you guys know if you click on the left side here where the text is, that'll download the link to your computer, which is the recommended way to do it. But if you want to just view it, you can click on that little icon there And then here is the practice test. It's kind of small here. Let me enlarge it a bit, make it a little easier to see. Okay. All right. Now, this practice test is something that I wrote a couple of years ago, back before the coronavirus had hit. And the way I did tests back then, and the way that I wish I could do tests now, because I really think it's a good way to do tests, is I always gave my tests in two parts. Part one, no calculators were allowed and no notes were allowed. So there were certain things that you needed to have memorized. Like for instance, you can see here about how to do sig figs. That's something you shouldn't need to look in the notes for that. You know, various definitions, accuracy and precision. Those are things you shouldn't have to look in your notes for those. So part one of the test, those were parts that the questions where they were relatively simple so that you could do them without a calculator, without any notes. Part two of the test, that's where you did need a calculator and you were allowed a one-page cheat sheet. Well, because of coronavirus, I can't do that now. So you are allowed to use a cheat sheet or a textbook or even the internet for both part one and part two. Well, actually, there is no part one, part two. So that doesn't apply, but you understand what my intention is here. So if you look at the first two problems, or at least if you look at the first problem, all I'm asking is how many sig figs are in these numbers. I really, really hope that you guys don't still struggle with that. That's pretty basic. You guys should be good at. Questions 2 and 3, those are ones that are ridiculously simple. All you have to do is just add or multiply numbers in order to get the final answer. So please remember, the reason I put these questions on here is not because I want to test whether or not you know how to add or multiply or divide. Okay? I want to test, do you know how to report the number with the correct amount of sig figs? So if you look up at the top here, you know this warning up here. It says, be very careful about using the correct number of sig figs. If you get an answer that's numerically correct, but which has the wrong number of sig figs, it will be marked wrong. And that will be the case next week for you guys as well. So when you type the number into Canvas, if you type it in with too many sig figs, Canvas is going to mark it wrong. Or if you type it in with too few sig figs, Canvas is going to mark it wrong. So be super careful about sig figs next week. Now, if you showed your work and you email your work to me, and by the way, I think I forgot to mention this. If you're going to email me your work, you got to do it before midnight on the same day as the test. If you email it to me 2 or 3 days later, I won't accept it. I need it by midnight on the day of the test. Okay. So if it was one of these incredibly simple problems, like problem number 2 here, where all you had to do is add 2 numbers together, then I'm going to mark it wrong and I'm not going to give you partial credit, even if you show me work, because like I said, the idea here is not to find out if you know how to add. So if you get number 2 or number 3 wrong, sorry, but no partial credit for that. But if you get one of the more difficult problems wrong, where you had to do a whole bunch of steps, okay, that's the one where you might get partial credit. Okay, question number 5 is a good one. I think that's probably worth talking about here. So if I am asking you to calculate the average speed based on what you see in this graph over here, I hope that you guys could do that. Tell you what, can somebody type into the chat box here? Tell me what you think the answer is to 3a. What do you think is the average speed in between the time t equals 0 and t equals 1? Interesting. I see 2 numbers in the chat box, and those 2 numbers are different numbers. Very interesting. And one of the numbers is in miles per hour. What are you smoking there? This is not miles. Okay. The units here are kilometers, not miles. Okay, it looks like now people are agreeing that the answer is 3. One answer that I quite often see is they say 3/5. But you guys are saying, no, it's not 3/5, it's 3. Why is the answer not 3/5? I mean, because if you look at the time in between 0 and 1, So you'll notice the rise there is 3 boxes. So the rise equals 3, but the run, if you count the number of boxes, you'll see that the run is 5. So it makes it look like the answer maybe should be 3/5, but you guys seem to agree that the answer is not 3/5. You agree that the answer is actually 3. And by the way, I agree. Okay, so Dylan is exactly right. Okay, when you're calculating the rise and the run here, what you need to do is you need to look at those 5 boxes and you say, well, you look and see what is our independent variable. The independent variable is the time as measured in hours. So 5 boxes does not mean 5 hours. 5 boxes means 1 hour. Okay, so the answer is 3. The answer is definitely not 3/5. Okay, now, what if instead of asking about the speed, what if I had asked about the velocity? Would your answer be the same or would your answer be different? Somebody type into the chat box or unmute yourself. Okay, so I see the word same with a question mark. Somebody want to say same with an exclamation mark instead? Okay, so Taituan says same with an exclamation mark. All right, so Taituan, why do you say it with an exclamation mark? Okay, very good. Okay, yeah, so it is not the same, okay? It is, I mean, the number part is going to be 3. So the velocity, the magnitude of the velocity will be 3. But what's the difference between velocity and speed? Velocity is a vector. You have to say the direction. So if all you do is you say the velocity is 3 kilometers per hour, wrong. You need to also say the direction. Oh, okay. Okay. So now I see Taituan is just saying, well, he said it because I asked you to, right? I said to. Okay. So if I ask you for velocity, you need to say 3 kilometers per hour, and you also need to tell me the direction. Now, some people are tempted to say 3 kilometers per hour to the north, but I say no. And the reason I say no is because there's nothing in the problem here that tells you whether the positive direction is north or south or east or west. So we have no way of knowing whether it's north or south or east or west. The only thing that we could do based on the information that we have here is we would say we would have to say it's 3 kilometers per hour in the positive direction. Okay. That's the way that we would have to answer it. Okay. Now, some of you might be tempted to say +3 because, you know, if I had done the graph like this, okay, and where it looked like that and the slope of there was 3, except it was -3. If that were the case, some of you would be tempted to say that the velocity is -3. And I would have a hard time marking that wrong. But I would really strongly prefer that instead of saying -3, you say that it's 3 kilometers per hour in the negative direction. That's the way I would prefer that you say it if it looked like this. Okay, if it's like this, then obviously it's positive. Okay, so see you later, Calvin. I recommend you watch the recording. Okay, so hopefully everybody's good on this. Be prepared for questions like this. Okay, so question 6 should be really easy. Question 7. So Jackson is asking, so saying negative or positive works for direction? Yes. In this case, I mean, because what else can you do, right? That's the only option that makes sense in this case. All right, number 8 should be straightforward. Number 9 is my favorite problem on this whole test here. Some of you who've already started in the test have already noticed in the practice test. Okay. What I've done in problem number 9 here is I have flooded you with a whole bunch of information, most of which is completely irrelevant. And then at the very end, after flooding you with all this information, then I say, okay, so what's the independent variable in this equation? What's the dependent variable? All right, so what I'm doing here is I'm just testing to see, can you wade through all this flood of water, of information, and figure out what's important, what's not? That's really what I'm testing here. Okay, so hopefully you can do that. Number 10 is a good question. I think we've already talked about. So the rest of these questions, oh, this one's 15 is a good one. Let's talk about 15. All right, so what I've done in this case is I've given you a graph of position as a function of time. And by looking at that graph, I want you to give me a graph of velocity versus time. Okay. Okay, hang on a sec. Somebody just entered the classroom. I have to let them into it. Okay, so how could we do this? How could we take this graph of position versus time and turn it into a graph of velocity versus time? Well, remember how we calculated the speed, which is the magnitude of the velocity, if you're talking about instantaneous? It's the slope, right? Okay, so all we have to do is look at the slope of this line at various points, and that will tell us what we need to put in for the velocity here. So what I recommend you do is you break it up into different sections. So I'm putting dotted lines where at places where I think something interesting happened. So I think most people would agree something interesting happened there. I'm also going to put a dotted line right here because I think that something interesting happened right there as well. What I see happening is I see that the slope right here, if I look at the something that's tangent to the circle, I see that the slope starts out as 0. And then right here, I see the slope is some positive number. So the slope has definitely gone up. And then right here, the slope is some higher number still. But in between here and here, that looks to me like a straight line. So when I see a straight line, that tells me that whatever object it is that's moving, it must be moving at a constant speed. So in between this section right here, I'm thinking we have constant speed. But prior to that, I see that the speed is increasing. Okay, so it looks to me like the velocity starts out at 0, and then the velocity increases until it gets to this point right here. And then the velocity levels out. Now, how about right here? During this section, during this part of the graph right there, what do you think about our velocity, guys? What do you think our slope is there? You guys need to type something in the chat box or else unmute yourself.
Oh, it wouldn't have a slope?
Well, it has a slope.
Oh, a slope of 0.
Slope of 0. Thank you. Yes. Okay.
Sorry.
Yeah, that's okay. All right. So during oops. Okay. So during this part here, the slope is 0. So that means that our velocity is 0. And then during this part right here, you see the slope is some negative number. So there we go. Okay. So this is what the velocity versus time graph looks like. Okay. That goes with the motion, the other one on top. Okay. So so there's the answer for part A. But if you look at part B, it says at 2 points in the drawing, something happens that could not actually happen in real life. So can somebody see the problem here? Where are the 2 points here where something happens that could not happen in real life?
A negative position?
Negative position can definitely happen. Nothing wrong with negative position. Negative position just means that you're on the negative side of the origin. Somebody else got an idea? How about if I help you out
When
by
it jumps from those different levels at like an instant?
Yeah, you got it exactly right. So Jackson is looking at this part right here and he's saying, wait a minute, that can't be true. There's no way that you can go from having some positive non-zero velocity 1 second and well, actually 1 instant. And then the very next instant, all of a sudden it drops down to 0. That cannot happen. It's just, that's not possible. Okay, and Jackson's completely right in thinking that. Okay, so we've got 2 points here where something happens that cannot happen in real life. One is this point right here, and the other is this point right here. And the problem occurred because if you look up here, okay, you see how we've got a sharp kink right there, and we've got a sharp kink right here. So our graph down below here does accurately represent what's happening up here. So the problem is actually up here. It's impossible to have a sharp kink like that because that means that your velocity is changing instantly, and that can't happen, all right? So what we need to do in order to fix this and make it realistic is we need to make it so that this is a gradual transition there, and this is a gradual transition there. And the only way that can happen is if we don't have a kink. That needs to be rounded there, and it needs to be rounded there. There's no way that we can have a kink. All right, so I think this is something important that everybody needs to realize. All righty, let's move on. How are we doing for time here? Yeah, we got just a few minutes. I think we have enough time to do one problem. All right. Oh, by the way, notice problem number 16 here is asking about the flat Earth activity. So be warned, anything we've done all year, including the flat Earth activity, is definitely fair game for the test. All right, so we got a bunch of questions. Number 17 is basically just seeing, can you come up with the equation that fits the line, which I sure hope you can. 18 is a conversion problem. 19 is a conversion problem. I would hope you guys are really good at conversion problems. Reading the graph here on problem number 22. I hope you're good at reading the graph. So tell you what, let's pick a problem like, 24. 24 is a good problem because that's about all we're gonna have time to do, and then the period will be over. Okay, so we got a car going down the road at a certain speed, and we want to know how far the car travels from the time we hit the brake until it comes to a stop. So hopefully at this point, what you guys are going to do is you're going to get out your template right here. Okay, this is the template that I posted to Canvas. So I hope that you guys print a bunch of these or just go ahead and make them up on your own. So what we need to do is we need to solve, well, we need to figure out what numbers go in each of these things. And then depending on which ones we are looking for and which ones we don't know, we use that to figure out which equation is the equation we want. Okay, so that's the procedure that we're going to follow. So let's go back here to the practice test. Come on. Why is it not going away here? Let me stop sharing here and then now restart sharing. Okay, so over on the left side here, I'm just going to go ahead and make a list of all those variables. I like to call them the Dr. Seuss variables, but you can call them whatever you want. So X initial, X final, V initial, V final, A, and T. Okay, so as we read the problem, let's see what ones we can fill in. So the car is going down the road at a speed of 24 meters per second. All right, well, let's draw the car. Here's the car. Okay, it's going down like that, 24 meters per second. And then it's going to hit the brakes. So that means our initial velocity here must be 24. Now, the question is it going to be a positive 24 or a negative 24? Well, that depends on what we choose to be the positive direction. The logical thing to do in this case would be to choose the positive direction so that it's in the direction the car is moving. But we don't have to if we don't want to. We could define it differently. But let's assume that we do that. Okay, so then we know that our initial velocity is 24. All right, the driver begins to push on the brakes and the car decelerates at a rate of 3.5. So does that mean that our acceleration here is 3.5 or does that mean that our acceleration is a negative 3.5? Well, hopefully you guys understand if it's decelerating, then that means that that's negative acceleration. Okay, all right. And we want to know how far will the car travel. So if they're asking how far does it go, then that sounds to me like we're asking what is x final. Now that's assuming that we have defined our origin so that the origin is located where the car is at the time that he first hits the brakes. I mean, that's the logical way to do it. So if we define our origin to be there, then by definition, that means x initial is 0. And now it says the car is finally going to come to a stop. So that means v final equals 0. All right. So now we look at what do we know and what do we not know. Okay, so x final is what we're looking for. So I like to put a box around it to remind me that that's what it's looking for. Nowhere in the problem here did it say what the time is. So we don't have a t. Okay, so now it's time to decide which equation we want to use. So what we do is we say, all right, well, hey, we're looking for x final. So whichever equation we choose, it darn well better have an xf in it. Otherwise, it's not going to do us any good. And we don't know what t is. So whichever equation we choose, it darn well better not have a t in it, because if it does, then we got two unknowns and only one equation. All right, so I want you guys to look in your notes and tell me which equation has an x final in it and does not have a t in it. Which equation is going to do the job for me? So look on the page where I have all those Dr. Seuss equations.
F of x squared equals v final equals v naught squared plus 2a delta x.
Okay, very good. Vf squared equals v naught squared plus, that's a squared. That's a terrible squared. Let me try that again. V naught squared plus 2a. Now delta x, some of you might look and say, well, we're supposed to be finding xf, not delta x. That's different, isn't it? Well, no, it's not different. Delta x just means x final minus x initial. Okay, so let's go ahead and just write it in there. Okay, so now that we've chosen which equation we want to use, then from this point on, it's no longer a physics problem. Now it's just a math problem, and you're good at math, right? Okay. So we need to solve for xf, and you can see that we're going to have to do a little bit of algebra in order to do that. Now, some of you are going to be tempted to take the numbers and put the numbers into the equation. Let me ask you, please, or let me request of you, don't do that. Whenever you need to do algebra, it's a whole lot easier to do the algebra using the letters than it is using the numbers. So get in the habit of doing the algebra using the letters, not the numbers, with one exception. Okay, there is one time when I would say it's okay to go ahead and put the numbers in, and that would be if the numbers are 0. Okay, so x initial, we know that's 0, so we can just get rid of that. V final, we know that that's 0, so we can get rid of that. So other than that, we don't put in the numbers. Okay, so we want to solve for x final. So let's subtract a v naught squared from each side. Okay, so that gives us negative v naught squared. Well, that v looks like a w, doesn't it? Okay, let's try that again. So negative v naught squared equals 2a times x final. So now let's divide both sides by 2, and while we're at it, let's divide by a as well. And let's see if I can, no, okay. All right, so divide that by 2, divided by a. I realize it's a little hard to see because of all the writing on there. I wonder if I, okay, does that make it a little easier to see there? Okay. All right, so that cancels that. And so x final equals this. Now, some are going to worry about that negative sign there. You say, wait a minute, how can x final be a negative number? Ah, the acceleration, the number we put in for acceleration is a negative number. So those negative numbers are going to cancel out. So we'll get a number that will in fact make sense. Okay. So at this point, I'm going to stop. There's no reason for me to go on. So guys, we're out of time. I highly recommend that you join me for class or join me for the study session on Friday, but I do not require it, but I definitely do recommend it. Okay, so those of you that need to go, so just go ahead and type bye into the chat box. I'm going to turn off the recording. So if any of you have any questions you want to ask that you don't want to get recorded, you can do that.